Hi, this is Nischal. Today I'm presenting my thesis report. It's partial fulfillment of my master's degree in pavement technology. The topic of my report is a review of the sustainability of using natural material in road pavement and application in the Northern Territory. Introduction. Natural occurring granular material are widely used for road construction in Australia. That is what we called natural gravel, and in many areas, especially in urban areas and states and territory, they use fine cross rock as a gravel material for road construction purpose. Considerable cost saving can be achieved if we use natural gravel. Obviously, we don't need to pay much, and there is no cost for haulage. In many cases, like many materials that have not met conventional selection criteria or is away from the specification, also have given the satisfactory performance in the past. So, using or without engineering intervention, so we can use the natural gravel with or without intervention, any engineering interventions. The another area of my study is sustainability. As you see in the uh, diagram here, for the sustainable road design, there is measure three environment is involved. Is one is operational environment, the second is local resource environment, and the third one is engineering environment. My research report mainly focus on engineering environment as we are an engineer, and among the engineering environment, my more focus will be on material property, that is what the gravel material for the road construction purpose. This slide shows how rock, gravel and soil formed. As you see here, there's lots of arrows. All the sedimentary metamorphic igneous rock, when they get weathered, it become residual soil. That is what is the source of natural gravel for the road construction. I have also compared the FCR like fine cross rock and the natural gravel. What are the difference in the properties like composition, aggregate, clay material, cement, hydration? All of these property is different in FCR and natural gravels, which we can see here. The other area of my study is like effect of wheel and pavement layer. As you see on the diagram here, the wheel load at the top of the pavement is more concentrated and is gradually decreasing in a wider area and goes to the subgrade. That's why we design a road with sub base, base and wearing surface to hold the wheel load and transfer it to the subgrade. If the natural gravel that need to form our base, subbase and other pavement layers are not of good standard, how to improve the substandard natural gravel? There are few ways to do it, like mechanical stabilization. Here in photo, what it has been done is mixing natural gravel and fine cross rock to get a conforming gravel. And other way to mix it as a mechanical stabilization is blending natural lateritic gravel with natural limestone gravel. Is both the natural, but when we combine them, it may give a good result. And other improving substandard natural gravel different ways are like cement stabilization, lime stabilization, bitumen stabilization, and chemical stabilization, which I have dealt on my report more deeply. There is one guideline for the binder selection for stabilization. So for the natural gravel, if it is not good enough and we want to put some binder as a stabilizing agent. Here is the guideline. It mainly depends upon plasticity index, and in the chart you can see the different color: green, yellow, red, and there are some cross. The green means usually suitable, and yellow means it is doubtful whether or not, you need to investigate it first, and the red is usually not suitable, and with the cross is we need something uh, pre-treatment before we treat with other chemicals, cement or bitumen. So there, there is involvement of 2 or 3 stabilization for one gravel. Another important part for the of my study is application in the Northern Territory. So if we go through this, it is really an achievement of my study, and obviously I think it is a good outcome for Northern Territory government as well. Highways in Northern Territory, if you see it here, uh, according to the Department of Infrastructure Planning and Logistics, they manage 22,000 kilometers of road network, among which there are few national or federal highways like Stewart Highway, Victoria Highway, and Barclay Highways. There are lots of arterial roads and secondary roads, which forms 22,000 kilometers of road network. This map is created by myself through GIS map. As you see in this map, it is widely sedimentary rock. In the yellow is the sedimentary rock, so you can see a wide predominant area of the sedimentary rock, and the brown is metamorphic rock, and the purple is igneous rock. So you can see a lots of areas of metamorphic and igneous rock as well. But when these rocks get weathered and with so many years of integration, it forms gravel. So it is not the area where we get the gravel, but that is the rock type here. This map shows better understanding of land use pattern. The brown area is more lateritic in nature, the blue is basalt, the yellow is sandstone, and in the desert plain that is pink, granite is dark pink, and alluvial floodplains are green. So you can see more land use pattern in this figure. uh, I have also prepared an individual like that brown, green, and yellow areas in individual map, as you can see here. This is only for elevated plateaus and lateritic plains and rises. These soil provide ideally naturally conforming road construction gravel with good particle size distribution and low to moderate PIs. So ideally we can use these gravel straight from the natural pit to the road construction site, and this landform dominates the central and southern west areas of the region. And this region I'm more focused on Catherine region, where I belong to and where I'm currently working to. The other map is only showing the limestone plain hills and rises. If you see here around Catherine region, and the west side has more limestone in areas. This limestone occurs in the central region around Catherine and in between basalt plain hills and rises, and sandstone plateau in the western region. Sections of the Stewart Highway, Victoria Highway, and Buntyne Highways are constructed from these materials a long time ago. All the sealing aggregate, not all, maybe most of the sealing aggregate manufactured in the Catherine is limestone, so you can see the aggregate a bit white in color of this region. Another map I have prepared is basalt plain hills and rises. As you can see, there are small patches on uh, east side of the highway, Eastward Highway, and there is a lots in the western side of the eastward highway, and along the Bontyne highway you can see a big patch of basalt plain, and also towards the Western Australia border. This landform dominates the western area known as Victoria River District, mostly west of Bontyne Highway, as I said in the map. The clay soil derived from the basalt provide high nutrition to the pasture and the stock that graze them. So you can see lots of cattle station on that area. That's why the Bontyne Highway is also called the Beef Road. Low hills and the basalt agglomerate and the top some dolerite, mostly rock outcrop with surface stone and pocket of clay soil. Red and blackened earth can be seen on the basalt plain. The granite plain and hills. You can see a small patch in the north of Catherine. That's the purple area. This landform only occurs for about 50 km of the eastward highway just north of Catherine. Typically, these soil provide no conforming gravel at all, but there are small response to lime or cement stabilization. So we don't most prefer this area as a good gravel source, but still we can use for minor repair and maintenance. The soil have a very low CVR and highly susceptible to erosion, so we need to be very careful using those gravel unless we are confident to use with the test results. This map shows where the quartz sandstone plateaus and plains and hills is fairly equally distributed from eastward highway east and west side. This landform dominates the unsealed network to the east of the eastward highway and the sealed Roper highway, and in the western areas of the Victoria River District. Typically, this landform presents a reasonable subgrade for road construction but provides limited access gravel resources. And still, most of the high PI soil of this type can be improved with cement powder and typically retain the high PI with addition of 50% FCR. So if we are working on this area, we can use cement or FCR mixing to make the natural gravel to the usable standard. This map shows about the dune field and sand plains. As you see, it's mostly on the desert area, the south of the Catherine region, and a little bit on the coastal side, on the east side. This landform is typically early deposits from either marine supplied source or in the desert region. The sources are not defined. They dominate along the coastal areas and in the central arid region. Due to the natural high calcium content, the soil won't respond to the lime addition, so we need to be careful if we are using lime. The lower clay sand to respond to moderate cement addition to form the strong on-ground pavements. And finally, this is plain and flats, like what we call alluvial soil. It is more about near to the river areas and in some plain areas. You can see a lot of branches on the map. This landform occurs across the region along the larger river coastal flood out in country and between lateritic plateau and rises. This landform typically presents a poor subgrade for road construction with very low CBRs and very high PRs. That's why it's more about black soil, where we need to be very cautious about using those gravel on the road construction. But if it is more sandy or loamy soil, we can strengthen by using cement powder to provide higher CBR. Finally, I have also done the cost analysis. In the analysis, I have used three different options that we have talked before, and it is a real project in Bontyne Highway which I have taken around 330 km from Catherine or 200 km from Victoria Highway. This is the first option that I'm talking now. In this first option, what I have done is non-conforming natural gravel mixed with in situ cement stabilization. So when we mix with cement and using exactly the same natural gravel material found in nearby of the project area, it costs $64,150 and 56 cents for 1 kilometer of road construction. Similarly, I have used 50% natural gravel and 50% FCR. I have taken the rate for FCR from one of the projects recently we have completed in Buntine Highway. So if we travel 40 kilometers from that FCR quarry to the site, nominated site, it will cost $117,280 per kilometer. So it is a bit higher than what in the first option is. And the secondly, cost analysis using imported natural conforming gravel from 100 kilometer haulage distance. If you see my first map, you can see a gravel, the brown layer close to Lazamana Road. So when we take the gravel from Lazamana Road and travel almost 100 kilometer, it's gonna cost $75,200. So compare with those three options, the first option is the cheapest. And the only thing I want to show with this cost analysis is, even though we have 3 or 4 maybe 5 different options, but we need to analyze before we finally say this is good in this area, because all have pros and cons. So before we choose any of the option, we need to analysis with the cost analysis, and then we will pick which one is best for that project. Finally, conclusion and recommendation for further research. I'm more focused on conclusion. Use of natural gravel in road construction with or without improving its characteristics can save considerable cost of the project. As you have already seen with my cost analysis, we can save some money if we use the natural gravel, and with some improvement, obviously it will reduce the cost and save money for the other projects. The conclusion is improvement to substandard natural gravel. If the natural gravel is not of the good conformance quality, it's not with the good standard, then we can use different options to enhance the property of the natural gravel to use in the road construction. So once we increase or enhance the property, then we can use those gravel in the road construction site. And finally, if you see on my chapter 7 of the report, you can see different land use pattern of Northern Territory. You can view and have a good study of the different areas, and it also shows the availability and also the nature of what type of natural gravel you can anticipate on certain areas of the Northern Territory. And you can see from there what is the possible improvement strategy that can be made for the project on that area. So it is a very good outcome of my study. With those maps, it's really a good outcome of this research, I think. And for the further research, like I have seen many material that has been used in the past which do not meet our specification conventional selection criteria, but it has satisfactory performance. So using basalt gravel in the Buntine Highway road construction is holding perfectly fine. So it's already been proven it is good, but still it is not according to our specification. So some section of Buntine Highway, we can take that as an example, but if we reconsider our selection criteria for this specification, we can broaden our specification and use such material which is already proven in real field. I think we need to do some effort and do some investigation around that area. And nowadays we have many recycled product like plastic is a huge problem of nowadays. So if we can use those type of plastic in road building industry, then obviously it will be a great achievement in the road construction technology. So I think it need further investigation. There are a few other areas as well, like enzyme, and people are doing for chemicals. So there are lots of areas that can be investigated. Um, mm, Thank you very much for listening my thesis presentation. If you have any feedback, please let me know. Thank you very much. Thank you.